the part 3 of our video, and then we're going to introduce the last piece here we're going to introduce is the horizontal stretch and shrink, and we're going to show how do we get reflections over the y-axis as well. Alright, so our first general equation we have is f of x equals the absolute value of a times the quantity of x minus h plus k. Alright, so now we introduce the b term into this. Alright, so the b, just like the a, has 3 different transformations that are involved. 1, if b is negative. Okay. If a was negative, we have a reflection over the x-axis. If b is negative, we have a reflection over the y-axis. So reflection over y-axis. And if we just take a quick look at what that is, just going to give you a little piece here. If this is our graph, let's say our graph is here. Our new graph, the reflection, would be reflected over the y-axis. So at this point, we'll go now here, and that would be the reflection of the y-axis. Right? So it reflects over the y, not the x. Okay. So if b is negative, we get a reflection over the y-axis. Second, if b is greater than 1, all right? A little different than what the a value is. If we said if the a value was greater than 1, then it was a vertical stretch by a factor of that number. And with the b, this is going to be a horizontal. It's the opposite. It's not a stretch anymore. Now it's a horizontal shrink by a factor of 1 over b. And what do I mean by this? Okay. So for example, if you have f of x is equal to the absolute value of 2x. Okay. The b value is greater than 1, so it's a horizontal shrink. But if you think about the word shrink, what does that mean? Small or large? When you think shrink, what does it mean?
Make it small.
Yeah, it's small, right? So if you think about it's small, then you think about whole numbers, right? Is 2, if I multiply something by 2, is it going to get bigger or smaller? If I multiply by 1/2, is it going to get bigger or smaller? Smaller. So I want to get the shrink to go somewhere small. So rather than saying by a factor of 2 here, this will be by a factor of 1/2. So this would be a horizontal shrink by a factor of 1/2. So it's 1 over that term, right, to make it a fraction. And in the third case, is if b is between 0 and 1. Again, this is going to be a horizontal, not a shrink, but now it's going to be a horizontal stretch by a factor again of 1 over b. An example for this one, let's say we have p of x equals the absolute value of 1 over 3x. Okay, my b value is between 0 and 1, any fraction, so it's a horizontal stretch. When you stretch, you tend to get longer or bigger. So I'm not going to say by a factor of 1/3 here. I would say by a factor of, I'm just going to use 1 over 1/3, which is the same thing as just saying 3. So by a factor of 3. So I'm just using the denominator in this case. Okay? So a vertical stretch, or I'm sorry, a horizontal stretch by a factor of 3. Take a look at our first example. We have f of x equals negative times the absolute value of 2x minus 2. Oops, sorry, I'm going to call that g of x. I'm going to bring back my original function, which is f of x is equal to the parent function, which is the absolute value of x. And I'm just going to write that equation that we had, a times the absolute value of b times the quantity of x minus h parentheses plus k. Do you guys notice a difference here in the first equation here in the f of x and the g of x? Yep. Yeah, perfect, right? So this has b times the quantity of x minus h. Here it says 2x minus 2. So if I were to ask you right now, what is the vertex of this problem? What is the vertex of g of x? What would you assume the vertex is? Okay, so 1, 0, negative 1, 0, 2, 0. Okay, so I would be led to believe that this would also be 2, 0 as well, right? Because I'm looking, okay, so this is my h value, my k value is 0, and I want to think my vertex is 2, 0. It's actually incorrect, okay? So the answer that came out first was actually correct. But how do we get there? Okay? So before I actually tell me what the vertex is, I want to get 2x minus 2 in this form. So the b value is 2, but I want to take the b value out of both those terms. How do I get the b value out of both terms? What is that called? Yeah, I want to factor this out. So I'm going to factor out the 2 here. So g of x equals the negative absolute value of taking out the 2, factor out the 2, leaving me with x minus 1, close it, and I'm going to leave it right there. Now that I factored out the 2, now it's in this form. Now I can say, okay, well, now I can tell what my h value is. My h value here is 1. My k value here is 0. And now from here I can say, okay, well, then the vertex here is going to be 1, comma, 0. All right, so double check. Once you factor that out, just double check. What's 2 times x? 2x. What's 2 times negative 1? Negative 2. Did I get back to that original? Yeah, so just quickly distribute back in, make sure you got it, and then you can say, and then put it in that form. Again, if you could do it from here visually and mentally, and you can see like, all right, I'm going to factor out the negative 2, or I'm going to factor out 2 and go from there, by all means, do it. But I personally would like to see you guys take this extra step for now, for at least the first 50 problems that we do, just to make sure we put it in your mind. All right, now we're here. Now let's write g of x in terms of f of x. So g of x equals the negative sign on the outside. We're going to keep that negative sign there. Negative. F of, now you can write this in two forms. I could just put this 2x minus 2 in there. And that's g of x in terms of f of x. Or if I wanted to, I could say g of x equals negative f of, and then write it out with the factored out 2. And either one of those are good. So this is g of x in terms of f of x. 1, let's get the transformations down. Give me a transformation. Give me one transformation. Yep. So the negative sign here in the front is a reflection over the x-axis. Good. That takes care of that negative sign. Yep.
A horizontal shrink by factor of 1/2.
So we have a horizontal shrink by factor of 1/2. Awesome. One more. So horizontal shift, 1 unit to the right. Beautiful. So that takes care of the 3 transformations in this graph. The negative sign in the front is my reflection over the x-axis. The 2 inside here, my b value is a horizontal shrink. Shrinks get smaller, so by a factor of 1/2. Minus 1 moves my graph to the right, and I have no k value, so there is no vertical stretch or vertical shift either. All right, and the last piece here would then just be to graph. I'm going to make myself a little table here just to make sure I'm on the right track. So I got x and g of x here. And I'm going to start, where should I start? Where should I always start these graphs once I figure this out? Start at the vertex, perfect. So 1, 0. All right, choose a number of an x value bigger than 1. Choose an x value smaller than 1. So 0, 2. And because my graph is symmetric, whatever y value I get for 0, I should get the same y value for 2. So let's just plug one of them in there. I have 2 times 0. So I'm going to plug back into this equation here to help me out here. What's 2 times 0? 0. Minus 2. Negative 2. The absolute value of negative 2. 2 times negative 1. So when x is 0, y is negative 2. When x is 2, y is also negative 2. Let's go another one. Let's go negative 1 and 3. Plug in 3. 2 times 3. 6. 6 minus 2. 4. Absolute value of 4. 4 times negative 1. Negative 4. So when x is 3 or negative 1, y is negative 4. So now we have five coordinates. Perfect. 1, 0. 0, negative 2. 2, negative 2. 3, negative 4. Negative 1, negative 4. And I'm going to just draw my line in between. Okay, so that's the safe way out. You don't have to do a chart if you don't want to. You could look at the function here. We got g of x is equal to negative absolute value of 2x minus 2. Okay. The coefficient here is 1. The coefficient here is 2. 1 times 2 is 2. So the slope is 2. You just have to realize which way you're going. So if you look at this, I'm going down 2, 1, 2, right 1. Down 2, left 1. Down 2, left 1. Down 2, right 1. Right? And that's just noticing because of my reflection over the x-axis. So you can get an idea of how many times you have to count. And again, this works primarily because it's an absolute value function. The absolute value function is linear. Yep. You can multiply. You can look at this: negative 1 times 2, and get negative 2. Yeah, your slope is negative 2. Absolutely. Just be careful with that. Just realize that it's going to go by 2's. Right? You should get a visual of the negative sign is going to be a reflection over the x-axis. It's going to be going down, and then just use the slope to help you go from there. All right, let's do another example. We'll make this one a little bit more challenging. This next example, I want to show you each transformation. Right? So let's start with we have our parent. Let's go to our parent function. F of x equals the absolute value of x, and let's go g of x equals the absolute value of x minus 1 plus 2. Let's go there first. So minus 1 plus 2, this is going to shift right 1 right and up 2. And my slope is 1, and my graph looks like so. Okay, that one's in red. Now let's throw a horizontal reflection over the y-axis, right? Let's throw that one in there. So let's go p of x in blue is equal to the absolute value of negative, and I'm going to keep the x minus 1 in parentheses because I don't want to change my vertex. So now I threw a negative 1 out here. So what this negative 1 is going to do is it's going to make this equation, make this graph, reflect over the y-axis. So all these points are going to reflect over the y-axis. So this coordinate here, the vertex, is going to reflect over the y-axis. So it's 1 unit to the right of the y, now it's 1 unit to the left of the y. This one is 1, 2 to the right of the y, so now it's 1, 2 to the left of the y. This one's on the y, so it stays on the y. This one, 1, 2, 3, so we go 1, 2, 3. This is 1 left, so now I go 1 right. So you just reflect over the y-axis. And you guys did this when you guys did transformations of polygons and reflect a triangle over the x-axis, reflect the triangle over the y-axis. It's the same concept, except now you're doing with graphs. Now let's look at one more. Let's throw another negative sign here. Let's go h of x equals negative absolute value of negative x minus 1 plus 2. So I'm building on to p of x. So after I reflect over the y-axis, now this negative sign will reflect everything over the x-axis. So it's just going to make all these negative. This one's going to stay here. And now all these coordinates become negative. And let's verify that one, right? So let's make a little table here, h and h of x. So I'm going to use the vertex, which is 1, 2. And I'm going to use 0. So if I plug in 0, 0 minus 1 is -1. Times -1 is 1. Absolute value of 1 is 1. Times -1 is -1. Plus 2 is 1. And I get my coordinate there. And that was to show you the differences between the negative sign outside the absolute value, which reflects now my graph goes downward. And the negative sign inside the absolute value does not change the direction of the graph. It still shows up, but it just reflects over the y-axis. Let's throw all our transformations in once. All right, we got f of x is the absolute value of x, our parent function. G of x is equal to -2 times the absolute value of -3x minus 3 minus 4. A lot going on here. All right. Still, I want my g of x in terms of f of x. G of x equals, the -2 is outside, beautiful, -2. F of this whole piece is what goes in here. F of -3x minus 3, close it, and then minus 4 on the outside. So the argument that's inside the absolute value is always what's inside the f of the quantity, right? To write g of x in terms of f of x. I could rewrite this one other way. G of x equals -2 times f of, I can factor out the -3 here, right? So I could say f of -3 times x. What does that become? X plus 1. Right? So be careful here. When I factor out the -3, it's negative, and I distribute back. It's -3 times x, which is -3x, -3 times +1, which is -3. So be careful when you factor that out. So these are both g of x in terms of f of x. Right? So let's look at that factoring out piece one more time, except I'm going to go right from the original equation. So we have g of x equals -2 times the absolute value and minus 4. So I want to be able to tell what my vertex is here. If I look at my vertex from here, can I say my vertex is 3, -4? No, I can't say that because I have a b value here. So before I decide what my vertex is, what should I do with that b value to that quantity? What should I do with that b value just to make it more safe or easier to see what the vertex is? I'm going to factor out the b value from here. So again, if we want to look at this, so this is -3x minus 3. Remember, when you factor out, it's like I'm dividing both of these terms by -3. I'm going to take the -3 here on the outside, and in parentheses, what's -3 divided by -3? X. And what's -3 divided by -3 here? Plus 1. Double check. I need to get back to this form here. What's -3 times x? What's -3 times +1? So a common mistake here would be to put x minus 1. But if I distribute back the -3 and I do -3 times -1, I'm going to get a +3. And I don't want a +3. I want a -3 here. So then here, this piece here would be -3 times the absolute value of x plus 1. From this form, now it's easier to see what the vertex is. What is my vertex now? Yeah, my vertex is -1, -4. It's still going to be my h, and it's still going to be my k. All right, so the vertex is hk, but get that vertex after you factor out the b value. After you do a bunch of these problems, and you can do it mentally, do it. For now, it definitely factor out. So now you have your vertex. We have g of x in terms of f of x. we have a lot of transformations here. Let's get some of these transformations down. Let's go left to right. First transformation, what's the first transformation we see? Yep. So the negative sign, we have a reflection over x-axis. Second one. What's the second one we see? We got the negative. Check. We have a 2 here. What does that 2 do? Vertical
stretch, a factor of 2.
Vertical stretch by factor of 2. That takes care of this one. Now we have a negative here. Beautiful. Reflection over the y-axis. Let's take care of the 3. What does that 3 do? It's inside.
Vertical shrink by a factor of 1/3.
Horizontal. It's inside. Horizontal shrink by factor of 1/3. Good. Let's take care of this +1 here. It's going green. +1 here. What does this +1 do? Horizontal shift. 1 unit to the left. And last but not least, let's take care of this -4 in the back. What does that -4 in the back do? Vertical shift 4 units down. So 6 transformations, 6 different transformations in this one graph. How beautiful. Last piece. We're going to graph this. All right? It's my first time graphing this function. To be safe, I'm going to make a table. Beautiful. So let's go x and g of x. Where should I start with this beautiful table here? Where should I start? My vertex. My vertex is, we said already, -1, -4. I'm going to go 1 unit higher, or 1 unit lower, to -2, 1 unit greater than -1, and these values will both have the same x value. It doesn't matter which equation I'm going to plug into, I'm going to go into here. 0 plus 1. 1 times -3. -3. Absolute value of -3. 3. 3 times -2. -6 minus 4. -10. So at 0, it'll be a y value of -10. And at -2, it'll have a y value of -10. Let's go one more, depending on the graph. So some of our graphs are not going to go so far. So you can use a different piece of graph paper or whatnot. Let's plug in 1. When x is 1, when x is 1 and when x is -3, you get the same y value. Let's go with 1. 1 plus 1. 2 times -3. -6. Absolute value of -6. 6. 6 times -2. -12 minus 4. So we got -16 here. Now on my graph, that's going to go off, depending on the graph paper. Go from there. So I'm going to plot my vertex, -1, -4. -1, 2, 3, 4. There's my vertex. And then the second point is -2, -10, which brings me down here. And 0, -10, which brings me here. That's going to go off my graph, so I'm just going to stop my graph there. And I'm going to draw my equation. One more piece to look at here. So you could do it with the table, which I think is the safest bet. Okay. But if you notice, how do I get from my vertex to the next point? if you look at this, I'm going to go down 1, 2, 3, 4, 5, 6, and right 1. So I kind of have a slope of -6. If you look at the coefficients here, right? G of x is equal to -2 times the absolute value of -3, x plus 1. So what is -2 times -3? Or what's 2 times 3? So my slope is going to be something of 6, right? You have to look at the reflections to tell which way you're going to go, which way you're going. So the reflection here in the front tells me my graph is going down, so I make sure I go down 6, right 1, down 6, left 1. So you can kind of cheat that way, and by looking at that way. And again, that works with the absolute value function best because both these lines are linear.